Hello friends, this is Vineet. Welcome to my channel Techies Hub. So today I have brought another video on software testing concepts. So it's just like going through some of the notes that I have related to software testing concept. So let's start the video. So we will start with software quality. So the software should meet the customer requirements, meet the customer expectations, and the cost to purchase and time to release. So those are some of the quality terms that the software should have. And there are two terms called SQA and SQC. So SQA stands for Software Quality Assurance, and SQC stands for Quality Control. So you might have heard about the QA and QC and all those stuffs. So the monitoring and the measuring the strength of development process is called SQA, and the validation of the final product before release to the customer is called SQC. So how to achieve this SQA and SQC? So we have a uh, diagram which actually is similar to a fish. So actually we have this requirement gathering section that starts, then we have the analysis, then we have the design phase, coding phase, and testing phase, followed by the maintenance phase. So the SQA deals with the starting phases like reviews, the design, coding, and the SQC, the quality control. They come into the picture in the later phase like system testing, black box testing, software testing, etc. So some of the types of document that we have is like business requirement specification, software requirement specification, high level design, low level design, etc. So moving to the second page, what is this business requirement solution? So actually, it defines the requirements of the customer to be developed. And what is SRS? So SRS defines the functional requirements to be developed and the sister requirements to be used. So what are the reviews? So it's a document level testing technique during this review. And actually, it's like the responsible people will be estimating the completeness and the correctness of the corresponding document. So there are three ways: there's walkthrough, inspection, and peer review. So in the walkthrough, it's like a document from the first line to the last line. And inspection, it's like it's searching for a specific issue in a document. And then we have something called the peer review. So actually it compares a document with other similar document. So what is a design? So actually it's a pictorial representation of the project or software that to be developed. And the high level document defines the overall architecture of the system. So actually a small example is given here. And then we have the low level design. So actually it will be something more detailed. It will take into picture the high level design, and it will be giving more defining the internal structure of the every module. And what's a program? So actually a set of executable statement is called a program. So software consists of multiple programs, and a program contains multiple statements. So what is a white box testing? So it's a program level testing. So in this technique, the responsible person are verifying the internal structure of the corresponding program. So these are also known as glass box testing, open box testing, clear box testing, etc. And what is a black box testing? So it's another kind of software level testing technique. But actually here the responsible people are validating the external functionality. So they don't want to know how it works internally and all those things. So let's talk about some of the software development lifecycle. So we'll start with V model. So V stands for verification and validation. So this model defines a conceptual mapping in between development states and testing states. So actually here is a pictorial representation on how it is defined. So you can see one arrow coming down and one arrow going up. So that's how the V is created. So the downward arrow is mostly related to the development team, and the upward arrow goes for the testing team. So the development team will be having BRS, CRS, and URS. So all those are business requirements or customer requirements, etc. And there will be user acceptance testing in parallel with what the testing team will do. Then for SRS, there will be system testing. And for HLD and LLD, there will be integration testing. And for coding, there will be unit testing. So also we have mentioned where we will be using the black box testing technique and the white box testing technique. So coming to the review and analysis. So in general, the software development process starts with requirement gathering and analysis. So in this phase, the business analyst category actually develops the BRS and SRS, and then they conduct some reviews on the document for completeness and correctness. So some of the questions that they have is, are they right requirements? So are they complete requirements? So are they achievable? Are they reasonable? And finally, are they testable? So what are the reviews in design? So after completion of analysis and the reviews, the designer category people develop HLD and LLD that I have discussed earlier. So the designers prepares these questions on HLD and LLD like, are they understandable designs? And are they meeting the right requirements? Is it the complete design? Or are they followable designs? Are they handling errors? So then we move on to the unit testing. So after completion of design and the reviews, the programmers start coding. So in this phase, the programmers prepare program and then test each program using white box techniques such as basis path testing, control structure testing, program technique testing, and testing. So in the basis path testing, so actually the programmer concentrates on the execution of program without any runtime errors. So actually that is the main intention of the developer. So the program should run without any runtime error. So there are some approaches that the development team use for this. So you can just go through it. So this is a picture representation. So something like a cyclomatic complexity is one of the scenario that actually most developers face when they do this kind of testing. So actually like a programmer gets confidence that the program is running only when the cyclomatic complexity is reached in running the program designed. So actually there will be a true and false condition. So if it is true, then do something, and if it is a false, then do something. Then we have control structure testing. So during this test, the corresponding programmer concentrate on the correctness of the program execution in the test. So actually they verify each segment of the program execution. So that means that each segment is based on the input and output. Based on the input, it is giving the correct output or not. And then we have the program technique testing. So during this test, the programmer concentrates on the execution speed of the program. So if the execution speed is not reasonable, then program performs changes, and it should be that they are expecting some speed, so they are planning to do some changes to keep that speed. Then we have something called mutation testing. So during this test, the corresponding programmers estimate completeness and correctness of programming testing. So you can see we have some example like that. So when it is the complete testing, and when it is the incomplete testing, and when the test case is passed. So then we will have something called integration testing. So that comes after unit testing. So after completion of the dependent program, so we will be interconnecting everything. So we have something called top-down approach, bottom approach, hybrid approach, and system approach. So in the top-down approach, so actually it's like the interconnection of main program and some sub-program is called top-down approach. So programmers use temporary programs called stub instead of sub-programs which are under constructions. So the other names of stub is call programs. So here is an example where since the sub2 is not available, they are using a stub. So the stub will be actually similar to sub2, but actually it will be developed by as something for temporary use by the developer. So it's not the main sub function. So then we have the bottom-up approach. So here the interconnection of the internal subprograms without using the main program. So actually the main program will not be available to connect to the subprograms. So here also they will be putting a driver. So in the top-down approach they use the stub, but in bottom-up approach they use something called a driver. So it's also called the calling program. So it's like in this approach the first modules are developed, then the parent module, then interconnect child modules and parent module. So if any modules are under construction, they develop something called a driver. So you can see in stub it is called as call programs, but in driver it is known as calling programs. Then we have the hybrid approach. So actually it's known as sandwich approach. So it's a combination of top down and bottom up. So you can see it makes use of both stub and drivers. So sub 1 is making use of a driver, and sub 3 is making use of a stub to connect to sub 1. In system approach, it is known as a Big Bang approach. So the program interconnect programs after completion of all programs development and unit testing. So once the developer completes all the unit testing and the development, they will interconnect. So what is a build? A finally integrated set of all programs is called a build or application under testing. So then we will move on to the system testing. So actually after this integration testing, a separate testing team receives a software build from the development team. So it has a set of black box testing techniques to validate whether the software that the software is actually satisfied with all the required conditions. So there are three types of system testing: usability, functionality, and non-functionality. So usability testing actually, so it's like whether the application is user friendly. So that's what we are trying to get out of this usability testing. So actually there is user interface testing and manual support testing. So those are the two subtests that comes under usability testing. So in the user interface testing, so actually it will be mostly on the percentage ease of use, the look and feel, and the speed of the interface, etc. In the manual support testing, there will be it's like the help documents, like the testing teams concentrate on the correctness and the completeness of the help documents for the business users or whoever using, so that they can easily move through the application. So actually there's a picture representation like the receives built from the development team. Then when it comes to usability testing, there will be user interface testing, then the functional and non-functional, then manual support testing. So the manual, between the user interface and manual support testing, we will have this functional and non-functional testing. Then we will be moving to the functional testing. So actually it's like the testing teams mostly concentrate on the customer requirements, and actually it has something called the functionality testing and the sanitation testing. So the functionality testing is it depends on the correctiveness of the every functionality. So actually we will be checking the requirement traceability metrics and all those things to make it is actually well within the defined limits. So we have something called GUI coverage, the graphical user interface coverage or the behavioral coverage. So it's like changes in the properties of objects in the screen. Then error handling, like preventing incorrect operation. Then input domain coverage, taking correct size and type of input. Then manipulation coverage, then backend coverage, then order of the functionality coverage. And then we have something called the sanitation testing. So actually it's also known as garbage testing. So during this test, the testing team identifies extra functionalities in software build with respect to the customer requirements. So we were talking about the functionality testing as of now. Now we will be talking about the non-functionality testing. So actually something like recovery testing, compatibility testing, configuration testing, inter-system testing, load testing, stress testing, volume testing, etc. So the recovery testing, it's also known as the reliability testing. So actually in this, the team validates whether the software build changes from abnormal mode to normal mode actually. So when that happens, so that's what is known as recovery. So from an abnormal to normal, how much time it takes to recover. So there are so many backup and recovery procedures for recovery testing. Then we have something called the compatibility testing. So actually it is known as the portability testing. So during this test, the test team validates whether the software build is running on customer expected platform or not. So actually it's like operating system, compilers, browsers, etc. Then we have the configuration testing. So it's known as the hardware compatibility test. So during this test, the testing team validates whether the software build is supporting different technologies, hardwares, etc. And just like the inter-system testing, so actually it's like how it connects to the back end, to the front end, then different resources of those things. Then we have the installation testing. So actually testing is something like we have the software build and the supported software. So when we install in a system, actually it should be like the setup should be easy and the setup should be available, and how much space it takes and all those things should be taken into consideration. Then we have the load testing. So actually it's like so the execution of our software build in a customer expected configuration environment under customer expected load to estimate performance is called load testing. So actually, it's like if three or more people are working on the servers, so whether how much load it can. So it like so how many people stand that can actually access the server and all those things. Then we have something called the stress testing. So the execution of our software built in customer expected configured environment under various levels of load. So in load testing, we will be only giving one load like 1000 load and whether we are checking whether it can handle. But in stress testing, we will be changing like 1000, 1500, 200, 2000, etc. Then we have the data volume testing. So during the testing, the team estimate the peak limit of data handled by our software build. Then we have something called the parallel testing. So it's known as the comparative testing or the competitive testing. So during this test, the testing team is comparing the recent software build with the previous version of the software and actually some of the competitive softwares in the market. So then after all these things, we will be moving to the user acceptance testing. So actually it's like the project management team who concentrate on the user acceptance testing. And the feedback from the user acceptance team will be considered. So actually if there anything needs to be changed, that it has to be done, because actually it will be the business users or the business analysts who will be doing the UAT testing. And so actually that's all about the user testing. Then actually after completion of the user testing and the modifications, the project management concentrates on the release team. So the release team consists of a few programmers, few test engineers, and some hardware engineers. So something like the port testing, test software changes. So those are some of the testing that we do on the release team. So what is a port testing? So the corresponding release team conducts port testing on the customer's site. So these are some of the observations on the factors while doing the port testing. So compact installation, overall functionality, input device handling, output device handling, secondary storage device handling, operating system with other handling, coexecution with other software, all those things. Then test software changes. So during the utilization of the release software, the customer side people sends change request to the organization. So to receive these CRs, the organization establishes a special team along with a few programmers, some test engineers, and project management category person. So this is known as the change control board. So actually the change request can be something enhancement, some analysis after some defects or impact analysis, then some software changes, and also it can be some missed defects and also some based on the mistake defects there will be impact analysis and then the software changes. So actually there is a table which gives details of the testing phase responsibility and testing techniques. So the review and analysis, it is done by business analysis, and the testing techniques are walkthrough, inspection, and peer review. Reviews in design, its responsibility is designer. There is walkthrough, inspection, and peer review. Then we have the unit testing, so it's programmer's responsibility, white box techniques. Integration testing, it's programmers, so top down, bottom up, hybrid, etc. System testing, test engineers, black box testing. User acceptance, it's real customers or model customers. So we have alpha testing and beta testing. So release, we have the release team which does the spot testing, and software changes in maintenance. We have the change control board, and that is the regression testing. Then we have something called an ad hoc testing. So in general, every testing team conducts planned testing, but testing team adopts informal testing also sometimes. So it's like this is known as ad hoc testing because we don't have the lack of time, lack of resources, etc. So there are different types of ad hoc testing. So one is known as black box monkey testing, then the buddy testing, exploratory testing, pair testing, and defect seeding and bugging. So actually, due to lack of time, the testing team concentrates on some of the main activities in the software for building for testing. So this is known as monkey testing or chimpanzee testing or gorilla testing. So they'll be mostly concentrating on the main functionalities, that's all. And in buddy testing, so actually the management groups, programmers and testers are as buddies, and every buddy group consists of a programmer and a tester. Then we have the exploratory testing. So due to lack of proper documentation of the software being built, the test engineer depend on the past experience, discussion with others, and so something like that, and they will test it. Then we have the pair testing. So actually, if there is a lack of knowledge on the domain, the management groups, actually a senior tester and a junior programmer developed and they conduct testing. So actually, they can actually share their knowledge between each other. Then we have something called defect seeding or debugging. So actually, to estimate the efficiency of a test engineer, the programmers add some bugs to the build. This task is called defect seeding or debugging. And then let's move on to some of the testing terminologies. We have a test strategy, test plan, test case, test log, error, defect and bug, a summary report, test bud, test suite, testing policy, testing process, testing standard, and testing measurement. So what is test strategy? So actually it's a company level document and it's developed by a quality analyst. So a testing strategy defines testing approach followed by the testing team. So what is a test plan then? So actually it's a schedule that needs to be followed by the testing team in testing. And a test condition to be applied on a software build is called as test case. And the result of the test case, actually it's passed or failed, is mentioned in the test log. So a mistake in coding is called as error. And this error detected by a tester is called defect or issue. But actually this defect, if it is found by the programmer, and then thus defects are also called bug. So then what is a summary report? So actually it defines a work progress like daily reports, weekly reports and monthly reports. And then test bud, actually the total testing information and testing environment is called test bud. So test suite, actually it's a combination of all the different test cases. Testing policy is a company level document and developed by the quality control uh, team, and actually it's actually some testing objectives will be there, so we have to follow those testing objectives. Then testing process, the proper planning before the testing is started. Then some of the testing standard like lines of code, the functional points, etc. And what are the testing measurements? So actually we talk about three, like quality assessment measurement, testing management measurement, and process capacity measurements. Then what is regression testing? So the re-execution of selected tests on bona fide build to estimate completeness and correctness of modification is called regression testing. So actually, in short, if some functionalities has been changed to a defect, so we will be doing the regression testing to make sure that it does not impact any other areas in the application. So actually, like you can see, the test, the build, it's passed or failed. So if it is failed, then it will go to the developers, then they have to modify the build and they have to do it again. But while doing the process, they have to make sure that whatever actually they would have put some fix on certain places. So the fix should have impact on other functionalities also. So the regression makes sure that the all other functionalities are working as expected, and the fix is only for the issue that we have and nothing else. So in the testing process, we have the test initiation, test planning, test design, test execution. So we have the test reporting, and finally the test closure. So the development team process is the testing process. So the first phase is always the same. It's like the requirement gathering and the analysis. And then for the development team, they will be having design, coding, and integration. And for the testing team, there will be test initiation, test planning, and test design. And then we will be having the test execution, reporting, and closure. So in the test initiation, the system testing process starts with test initiation. So actually, they will be going through the requirements and they will be selecting reasonable test. And actually, there will be the test strategy document or also known as the test methodology. So the SRS will be finally becoming strategies. So the test strategy document consists of the scope and objective, the business ideas, business issues, the approach, the roles and responsibilities, the communication and status reporting, testing measurements and metrics, change and configuration management, test automation and testing tools, defect reporting, risks and assumptions, and training plan. So actually, it's like what is the purpose of testing in this project? And so actually, so selected a list of reasonable tests. So what are the risks and responsibilities, and the negotiation between the jobs in the testing team. Then maintenance of the deliverable for future reference, which are the test automation tools that we are going to do, and how we are going to handle the defects and all those things. So these there are some test factors we'll be considering while doing the testing. So actually, like authorization, so the software which allows valid users and prevent invalid users. Then access controls, so authorities of valid users to use specific functionality. Then audit trail, data integrity, the correctness, the continuity of processing, the coupling, the ease of use, the ease of operations, the portable, the performance, the reliability, the service levels, the maintainable, and the methodology. So actually, we have some case studies which deals with all these things. So the CEO deals with the percentage quality software. The project manager deals with percentage of test factor. Test lead with testing techniques and test engineer with percentage test cases. So these are there are some test factor and the testing techniques that you use. So you can see like for authorization, we use security testing and all those things. So you can just go through those. And case study 2 is also something related to the above example, 9 factors are finalized to be applied in the system testing of a project. Okay, so you can see there will be actually 15 factors will be there, and during the requirements phase you have taken out 4. So then there will be only 11 factors. So out of this 15, only 11 will be there. And later some requirement got added. So you will be adding 2 more factors. So it became 13. And because of risk, you have taken 4 factors. So after finally you will be only having 9 out of these 15 factors. Then after initiation, we will be having the test planning. So after selection of reasonable test to be applied, the project manager or the project test manager releases the test strategy document. So the test lead concentrate on the test plan preparation. So actually there will be one test plan, system test plan and multiple detailed test plan. So it's like test strategy, a BRS, SRS development plan, then team formation, risk identification, prepare test plan, review test plan, and then the test plan will be circulated within the team. So actually, the test planning process starts with the testing team formation. So at the time of formation itself, we will start. And the tested, so actually it will be depending on the below factors. So the percentage of the project phase, availability of test engineers, test duration, availability of the test environment resources. Then we have the risk. So actually, so after the completion of the reasonable testing team formation, so then they will be moving on to the risk, like lack of knowledge of the testing team on domain, then lack of time, lack of resources, lack of documentation, delays in delivery, lack of rigorous development process, lack of communication, etc. Then we will be preparing the test plan. So actually there will be like the test plan ID, the instructions, the test items, then the features to be tested, features not to be tested, those are out of scope, the approach that we are going to use, and which environment that we will be using. Then what is the entry criteria? So actually the completeness and correctness, and then the test environment. So actually for the testing to start, there should be the complete and correct requirement, then the test environment should be available, then we should get the stable build and all those things. The suspension criteria, so when we can suspend this testing, then the exit criteria, then the test deliverable like scenarios, test cases, test logs, and staff and training needs, responsibilities, schedules, risk and assumptions, and finally approvals. Then we will be reviewing the test plan. So actually, after completion of this test documents, So actually the test lead will conduct a review meeting to check the completeness and the correctness of the document. So actually it's like so the test plan actually it will be a requirement oriented review. So testing techniques oriented review and risk oriented review. Then after the completion of above review, the test lead provides training sessions to selected test engineers. So the test training. So actually the it's this training is for the entire team to understand the complete project requirements. So then we'll move on to the test design. So after the completion of the required number of training session, the responsible test engineers concentrate on test case selection. Every test case defines a unique test conditions to validate the software built in terms of usability. So actually, it's like a unique test condition that we need to execute to make sure that the software is not breaking. So actually, it can be usability, it can be functional, or it can be non-functional. So there are three methods to prepare test cases. So functional and system specification based test case design, use cases based test case design, and or application prototype based test case design. So in the functional and the system specification based test case design, so it will be mostly based on the BRS, SRS, HLD, and all those things. So actually they have the approach like what they will be doing in the functional and system specification. So actually we have an example here like how we create the test cases for the functional specification based on the boundary value analysis and all those things. So if you want, you can just go through it. So similarly, another example is also there. So a couple of examples have been provided here just for the reference. So test case title 1, verify where the door opens. Test case title 2, verify the door closes, or something like that. So you can see it's based on the boundary value analysis or equivalence class partition. So based on that only the test cases are designed like verify card insertion, verify operation with the wrong angle of card insertion. So these are scenarios based on the uh, cases that they have provided. So it will be helpful if you are trying to create test cases for different scenarios. So then we have something called use cases based test case design. So in some situations, the testing teams converts functional and system specification in SRS into use cases to maintain complete and correct information. So this is possible to outsourcing testing organization. So in this, the test engineer will prepare test cases based on the use case. So it's similar, but instead of going with the BRS and all those things, they will be using the use case. That's all. So the use case will be having the use case ID, the use case description, the actors, then the precondition, then the action, post condition, alternative flows, flow graph, prototype, and exceptions or rules. So that's something the use case format. So actually some of the other cases, so it's like example usability test case. So verify spelling in every screen test, verify color uniqueness, verify no font uniqueness, verify size uniqueness on every screen. So then the review test cases. So after completion of selection of all reasonable test cases, the test lead conducts a final review. So the test lead concentrates on those test cases. In this review, the test lead depends upon the test factors. So the requirement oriented test case review and the test cases testing techniques oriented test case review. Then we will be having the execution. So it's like we will be actually running the test cases to make sure that we are getting the expected result. So the build release process, the build version process, and the
defect tracking system. So the development team and the testing team mostly concentrate on all these things. So they will leave the development environment and the testing environment and the development document. And the testing team will be working on the environment, and based on the issues, they will be raising defects to the development team. So the development team fixes if it's valid, and so the execution will be continuing until all the test cases are completed and all the requirements are satisfied. So you can see the development starts with the initial build, that's a level 0, and and then the feedbacks will be provided to the development team. So until and unless it becomes a stable build. So then there will be the level 0 sanity, which will be done by the testing. So when we move to the level 1, so the comprehensive or the real testing. So actually we will be having a stable build, and there will be defects raised. So there will be defect reports, and the development team will be fixing it, and they will be resolving, and then the modified will be coming. So that will be the regression testing, and the level 3 will be the final regression. So we'll start with the sanity testing. So after the establishment with the required software and hardware, then testing team conducts sanity testing to estimate testability of the initial software build. So actually, if we start with a comprehensive testing, then if that build itself is not testable, then we are wasting a huge amount of time. So before that, we will do a small sanity to make sure that some of the functionalities are available. So the testing team estimates testability with the help of below factor like understandability, simplicity, operability, observability, consistency, maintainable, automatable, and controllable. So sometimes the sanity testing is also known as smoke testing, testability testing, or tester acceptance testing. Then we have something called level 1, which is a comprehensive testing. So actually once the build is stable, so actually in the testing team will start executing the test cases as batches. So it's known as the test suite and all those things. And actually, so it's like it can be done by either a automation tester or a normal manual tester. So actually, it will be like a detailed testing on the functionality. So there will be something like passed, failed, and blocked status and all those things. So you can see a small life cycle test cycle like test cases, test branches. Then there will be skip. Some test cases will be skipped. Some will be blocked. Some will be uh, executed, passed, failed, closed, something like that. Then we have something called level 2, the regression testing. So actually it's like there will be so many defects, or after accepting those defects, the development teams perform some changes and they will release it. So the testing on this modified build to ensure the completeness and the correctiveness of the modifications on the build. So here there will be like the some scenarios are given with high priorities and medium priorities and low priorities defect. So actually it's like if the defects are resolved by the development team and is of high severity, the test engineer re-execute all P1s and carefully selected P2. So based on those severity and priority only, it is for the tester to decide which all test cases needs to be re-executed. So then we have something called level 2 regression testing. So the testing people uses two indicators for modified build, check-in and check-out. So check-in, regression testing, and check-out. So that's as simple as that. Then we have something called a test reporting. So during level 1 and level 2 test execution, the test engineers report mismatches to the development team. So the format is like we have the defect ID, the description, the build version ID, the feature, test case name, is it reproducible or not, then test plans and severity. Some of the severity like showstopper, medium, low, so all those things are there. Then we have something called the priority. So priority is with respect to the customer. So and then it's like status, so new, reopen, then the detected, then when it is detected and it's assigned to who, and the suggested fix. So there is a large scale organization picture which is represented in this diagram. So actually it's like if the project manager the test engineer who has, reports to test lead, then to test manager, and then the project manager. So in the other organization, it's like the project manager the same way, but it's like the hierarchy will be little bit simpler. And in the deferred life cycle, you can see, so there will be new, rejected, or deferred. So rejected means that they cannot reproduce or it's not a defect. Deferred means it will be taken in a future period. So it's open, then it will be closed, or if there is an issue, then it will be reopened and all those things. So this life cycle varies from organization. So actually that's based on how the organization wants the life cycle to be. And some of the metrics that we have, one is the defect density. So actually it's like the average number of defects found in a module or a function is called the defect density. So actually with that, actually I complete my small video on the software testing concept. So I believe it would be of some use to everyone. Thank you for watching the video and have a good day.